Hello, my name is Dave Burnison. I'm a technical advocate with the GitHub and Azure DevOps teams here at Microsoft. And I'm so excited to be here today to talk to you about how Microsoft embraces a DevOps culture and uses DevOps to build applications of the future. So let's dive right in. The future is more innovative than ever, and modern engineering methods have paved the way for a new kind of application. The app of the future is cloud native. It's intelligent, using things like speech recognition or machine learning or visual recognition to allow you to search for items on an e-commerce site, or and it's built upon the foundation of others' work through open source and inner source and centered on customer experience. Now, creating the app of the future is only possible with modern engineering methods. To solve problems, to adopt to new tech, and collaborate across teams, organizations need DevOps. But let's make sure we understand what we're talking about when we talk about DevOps. If you ask 10 people to define DevOps, you're probably going to get 12 different definitions. But at Microsoft, here's the working definition that we use. This came from Donovan Brown, a principal cloud advocate here at Microsoft. DevOps is the union of people, process, and technologies to deliver continuous value to end users. Now, you'll notice here, the first thing that we emphasize is people. And that's because even if you're using the latest and greatest processes, Scrum, Agile, Kanban, whatever it may be, or you have the greatest technologies in the world, everything that Gartner and Forrester and everybody else recommends, if you don't have all of your people collaborating together and they're in the same boat and rowing in the same direction, you're still not going to have the success that you need to move forward as a business. Now, what I like to say about DevOps is DevOps is to software development what the assembly line is to automobile manufacturing. But it's even more. It's also the logistics to get software to end users, much like delivery logistics get vehicles to dealers. Just think about the strides that our society made moving forward when Henry Ford created and implemented the assembly line. He democratized the ability for average people to own cars. And so what does this mean for you? If you can set up an efficient, robust, resilient assembly line, you will innovate faster than your competition. So what does this mean for the use of DevOps within Microsoft? We're going to talk about the Azure DevOps team's DevOps journey over the last 10 years. But this goes well beyond just the Azure DevOps team. Today at Microsoft, we've got over 100,000 engineers using the DevOps platform. There's 85,000 deployments a day across Azure DevOps, uh, different Azure services, Xbox, Office, etc. There's well over 2 million Git commits per month. So we have really learned how to do this at scale, but we're constantly learning and constantly trying to improve and constantly working to ensure that everybody is working with the same mindset, the same tools, the same processes. So I'm going to talk today about the Azure DevOps journey. This is our 10-year journey of going from shipping Team Foundation Server out once every 2 to 3 years to today, we ship updates to Azure DevOps services every 3 weeks. And our journey along the way for doing that and what we've learned, and we want to share that with you here today. Now, a key part of this came to be in 2014 when we created our One Engineering System, or One ES. That's Microsoft's Center of Excellence for software development. And One ES takes the best practices from any team, whether it's Azure DevOps team or the Windows team or a team putting together Azure Kubernetes services, and helps distribute those best practices to other development groups. But they also bolster our usage of tooling such as GitHub and Azure DevOps to provide additional functionality and enable all teams across Microsoft to leverage that functionality. So there's 5 key things we want to talk about today, the things that we have done in our DevOps journey. And the first is creating clarity. We're going to talk about how we adopted objectives and key results to create clarity across engineering teams and change how we measure success. We're going to talk about how to become customer obsessed. Now, we've relied on idea to data, which involves updating our key performance indicators and collecting telemetry to continually measure the value our products bring customers. Third, we'll talk about how we've evolved to full stack teams. Engineering teams own the entire lifecycle of a feature from inception through operation. And as issues or incidents arise, engineering teams are responsible for owning the customer response. And then next, talk about how we changed how we collaborate, develop, and deliver. So developers own that end-to-end lifecycle of their products. And this means introducing ways to better collaborate on code, raising the quality bar, and adopting things like feature flags to get early feedback. And then building for resiliency. We've trained people to be responsible for operation, fixes, troubleshooting, and ownership in production of each line of code they write. So again, we're going to talk about these 5 areas. So let's dive in. The first one we're going to talk about is creating clarity. And this starts with making the shift from measuring outputs to measuring outcomes. So an example of an objective and key result, or an OKR, an example objective is we want to grow a strong and happy customer base. And we'll measure this through measuring things like, are we increasing our net promoter score? Is the documentation satisfaction score going up? How's the pipeline, the new pipeline flow has an AppDex score of 0.9 or higher. Now, that AppDex score is a measure of performance. And is that performance increasing or dropping? What's the queue time for jobs? Is that less than 5 seconds? So now these key results are measured each quarter. And these best key results are leading indicators. And what we want to do is we want to encourage ambitious key results. So if we hit 70% of our key result targets, then that's a green score. So the idea here is you don't just want to go for what's probable, you want to go for what's ultimately possible. You want to set a high bar and really strive for great things. So when we talk about good metrics being leading indicators, we want to get away from trailing indicators such as measuring revenue, work accomplished, and bugs found, and shift over to measuring the leading indicators such as what's the monthly growth rate of adoption? What's the change in performance? Is it going up or is it going down? What's the change in time to learn? If we have a hypothesis that a new feature is going to provide more value to our customers, are we learning about that quickly? Are we validating or denying that hypothesis quickly. And what's the change in frequency of incidents? And we want to eliminate unhelpful KPIs. And again, we want to measure those outcomes, not the outputs. So we've got away from measuring things like original estimate, lines of code, team burn down, number of bugs found, code coverage, and things like that. We have new ways of measuring bugs found and things like that. So we want to encourage you to change what it is you're tracking. Focus on measuring only the most critical and impactful leading indicators as KPIs, such as customer usage. How much value are users getting? Is the software and solutions that we're delivering really making our customers' lives better? So are we acquiring more customers? Are we retaining more customers? Do our customers stay engaged with our solution? Are they satisfied by measuring Net Promoter Score? And are they using the new features that we introduce? Pipeline throughput. How efficient is the DevOps process? What's our time to learn, or time to build, time to test, time to deploy? Are these things going, is our performance improving? If performance is dropping off, then we're not going to be delivering value to our customers as efficiently and as effectively. What's our live site health? We know that issues are going to happen. As hard as we try, we've learned we can't get into paralysis by analysis and try to make sure that everything's solid, robust before we go to production. We try very hard, but we know there's going to be issues in production. So how quickly can we detect and fix those issues? What's the time to detect, the time to communicate those issues, the time to mitigate those issues? And then, can we have incident prevention items added to our backlog, making sure that if there's live site problems that have been sitting out there for a while, making sure that we can address those and bring down the time it takes to respond to those issues. But then another thing is, we've also learned, especially now with COVID and the pandemic and everybody working from home, we need to also measure employee health. How can you understand how your employees are doing? You want to monitor for burn down or monitor for burnout. Administer surveys to gather employee concerns and track vacation time. Not to say that we don't want employees taking vacation. We want to encourage employees to take the vacation time that's due to them so that we can avoid burnout and make sure that we have healthy, engaged employees. All right, so now another big influence in all of this was the book Drive from Daniel Pink. And so this helps us learn not only how we can set these objectives up at the highest level, but how can we make sure that those objectives and key results that we set at the top levels are being applied at the individual team levels, and make sure that what the objectives and OKRs that teams come up with are in alignment with the overall service and product objectives. But key things that we learned from this book are, we want to give our development teams three things: autonomy, mastery, and purpose. Those are things that really drive people to do great things. So we've learned from this book, there's things that we need to talk about. The organization. How are the various organizations set up? What are the key roles that you need within the organization? How to structure teams? What's our shipping cadence? Taxonomy. We want to make sure that everybody's speaking the same language. How do we plan, and what practices are we using to ensure that everybody's working in the same way to hit those outcomes that we want? So for planning and practices, That's where we give teams autonomy to manage things the way they see fit, the way that they best see fit. But we want to make sure that our teams are aligned across uh, across the board, so that we make sure that we're all speaking the same language. Within a product or within a solution, we're all of the teams are shipping on the same cadence, and things like that. So when we lay out our OKRs, we start at the product level first and then bring it down to the service level. So for something like Azure DevOps, you have the various services of Azure Boards, Azure Repos, Azure Artifacts, Azure Pipelines, et cetera, et cetera. So taking those product OKRs and bringing them down to that level. Or if we're talking about Office, you would be talking about the services of, Office 365 and our mobile apps, and then looking at things across Word, Excel, PowerPoint, et cetera. And when we get to the team level, we want to make sure that those team OKRs are aligned with the service and product OKRs. So we're all in the same boat, rowing in the same direction, rowing towards that same North Star. All right, so moving on from creating clarity, let's talk about being customer obsessed. A key thing here is we have altered our definition of done. Definition of done is not just the developer has completed all of their tasks and run through all their unit tests and merged the code. No, definition of done means that products are live in production and collecting feedback, because we want to collect telemetry data that examines the hypothesis that motivated the deployment. In other words, we may have a hypothesis that if we add feature X to product Y, our users are going to love that and our user adoption and engagement is going to increase. So we want to gather information and feedback, making incremental changes. Gathering information and making incremental changes is key to improvement. So we want to treat the goal as a question rather than a statement of fact, and see how that motivates developers to continue testing their ideas. So another thing about being customer obsessed is we want to take a zero distance approach by listening to your customers. And an example with Azure DevOps is we have ways built right into the service itself so that our users can report bugs or make suggestions right from within Azure DevOps. And that feeds into the developer community. And then within the developer community, I can go out there and look and see maybe somebody has made a suggestion similar to the suggestion that I want to make. And if they have, I can go out there and vote on that. And then at Azure DevOps, we look at all those suggestions and reported problems and then turn those into work items that we can then act on within a future sprint with Azure DevOps. So, and then we also ask our customers, would they recommend using Azure DevOps to a friend or a colleague? Or would they recommend using Azure pipelines to a friend or colleague? That's an example of taking the Net Promoter Score questions down to the service level. And so we can measure, user satisfaction over time. Is it increasing or is it dropping off? And is it dropping off as a result of recent deployments? Maybe there's feature changes that we made that users aren't exactly thrilled with, or maybe performance has dropped off. But by gathering that feedback, we can determine what is it that we need to focus on to increase the NPS scores and user engagement and things like that. And we've even gone as far as setting up or working with our top customers. We have a program here called Azure DevOps Champs. And so myself, I have a couple of customers on this list that you see here that I work with frequently to understand their requirements and build long-term relationships. I keep them informed of what's coming down the pipe on our roadmap and listening to their concerns and feeding those concerns back to the Azure DevOps product group. So with all of that, we can we can be assured that we are hearing our customers and applying what we hear from our customers into our products to make them even better and to make sure that we're delivering value to our customers on a repeated basis. All right, so moving from customer obsession over to evolving to full stack teams. So let's talk about the history of our organization. In the past, we had a silo of product management and a silo of development, a silo of testing. You know, back in the days, you'd say, well, development's done. Let's throw it over the wall to our QA team so now they can do their testing. And we realized there, lots of problems there. Developers would work on something, hand it over to testing, and it may be days or weeks before QA would come back and say, hey, there's a bug here. And, development would have to get their mindset back into what they were doing a few days or a few weeks ago to then really be able to dig in and look at that bug. So a first step we took was we combined our development and testing teams to create a single engineering function. So now developers and testers are working together side by side. And we even evolved the roles of development and testing into an engineering role. So now developers are writing unit tests for all the code that they write. And testers have gone from just writing automation tests to actually writing code and becoming engineers themselves. And then the next step was taking that product management silo and, oh, sorry, the next step was looking at operations and site reliability engineering. And what we wanted to do was to bring all of these capabilities, program management, engineering, operations, site reliability engineering, into single feature teams. So now a feature team works together and owns their feature set from conception all the way through to deployment and monitoring in production. So if we look at this another way, it means getting out of these silos of specialization. In the past, maybe as an engineer, you were focused on the API layer, or another colleague of yours was focused on just the UI. But what we want to do is, rather than having singular capabilities across our teams, we want to ensure that we have capabilities across all of these areas. Now, this doesn't mean that any one person has to immediately become an expert in all areas, but through collaboration and teamwork and working together, we want to bring up everybody's level of knowledge and expertise across all of these areas. So what does this mean for our teams? Uh, Prior to the pandemic, teams were located in physical rooms such as you see here. The feature teams were made up of cross disciplines, so program management, application developers, middle tier developers, site reliability engineers. Now, each team typically has an engineering lead and a product owner, and then 10 to 12 engineers. Now, these teams are self-managing. So when we talked about, teams creating OKRs that are aligned with service level OKRs and product level OKRs, teams are empowered and entrusted to manage their work and their progress towards completing those objectives and measuring those key results. And we keep those teams intact typically for 12 to 18 months so that we can ensure we've got continuity there for a while. And another key thing is that teams own the features in production and they own the deployment of features. Now, another way to look at this is taking a look at what these engineering teams actually do. Start out by framing the hypothesis and coming up with the specifications and design, doing feature development, doing code reviews. Every piece of code is reviewed, and that's a great opportunity for collaboration amongst team members and share knowledge and have junior engineers learn from senior engineers, or even senior engineers learning about new ways to do things that new engineers may bring to the team. Uh, Engineers are responsible for their own automated tests. Engineers are responsible for their deployment pipelines and configuration scripts and deployment management. So, they're responsible to say when, okay, things look good in development or, ring zero, now we can approve that and let that deployment go on to the next level, whether it's the next deployment ring or whether it's your QA environment or whatever that may be. These teams are responsible for secure design. If there's a security audit, they're responsible for any remediation tasks that may be needed for uh, remediating those security audits. Production support and more uh, even more that the teams are responsible. So like I said, they are responsible from the time that we conceive a new feature until it's deployed in production. It's running in a very performant manner. We know that the code and the deployments and everything are secure. All right, so moving on to the next area, we want to talk about changing how you collaborate, develop, and deliver. Now, the first area to talk about here is collaborating on code. Today, 90% of large enterprise applications are made up of open source and inner source. So we're pulling packages in from open source, or we're pulling packages in from other teams. Maybe the Xbox team comes up with a way to manage customer accounts here at Microsoft, and that code is something that with just a few tweaks, let's say the Office team could use or something like that. But that's not something that we'd want to put out there in the public space necessarily because it has specifics to Microsoft. So by taking those open source concepts and using them internally, we call that inner source. But we can leverage those things to really accelerate what our teams can do. So we want to build upon those open source projects that use global contributors. And we also want to encourage our team members to contribute back to open source. Microsoft has become the largest enterprise contributor to open source in general. We want to customize and adapt and reuse existing internal code, like I mentioned in that example before. We want to be able to collaborate with developers across your organization. So yeah, by doing the code review on a pull request for code within your project, you can learn from your other team members. But if you contribute to an inner source project, then you can learn from development experts and engineers across Microsoft and across your organization. So with inner source, you also want to appoint a smaller team to make the final decision so that you know that everything that's being contributed to those projects, inner source projects, is not only following the 1ES standards for quality and reliability and resilience, but it's following your team's standards as well. Now, another key area to talk about in changing how you collaborate, develop, and deliver is driving towards test automation. Now, the screen here that we're looking at, and let me make just a little adjustment here so that we can see everything. There we go. This is a picture of how we evolved in our approach to automated testing. Back in that 2010, 2012 timeframe, the orange bars you see here represent the automated tests that we had back then. And they were full end-to-end automation tests. But what we found is, yes, we had thousands of automated tests that would run, but to complete an entire suite of automated tests, it would take in the neighborhood of 22 hours to complete a test. So, or complete a full suite of tests. So it's very difficult to get fast feedback. And because those tests ran so long and we couldn't get that fast feedback in a timely manner, rarely did a full test suite run return with all tests being green. So it was very hard to ensure that if you added one piece of code here, it wouldn't break something over there. So we had to change our approach to automated testing. And this took about 2.5 years. This is the representation of the Azure DevOps 3-week sprints over that period of time. And we changed our approach to automated testing. We realized we had to break things down first into these different level of testing, L0, L1, L2, etc. So what we did is come up with these L0 tests that run as unit tests. And those are the tests that you can run on every build, on every pull request to ensure that you've got uh, got really good test coverage, but those tests are going to run really fast so that you can get fast feedback. And then building upon that with the next level of test to add SQL and file system and run those in pull requests. And then when we create a pull request, we'll have other pipelines or workflows that run in parallel to do those L2 and L3 tests to branch out and start running tests that work with the REST APIs or tests that run the full test environment end to end. And those L2 and L3 tests, they may suffer from some latency and things like that. So it's going to take longer to complete those tests. But we can get fast feedback from those L0 and L1 tests, but in the long run, ensure that we're getting full test coverage by having those parallel workflows and everything in place. So we have these tests now that anyone can run from anywhere, including production. And we shifted unit tests, shifted away to unit tests from full suite of automated functional tests. And those core tests run before a pull request. That way we know they're fast and we get 100% reliable build and test. And that's critical to making sure that we can continuously deliver without breaking something over here when we change something over there. And so let's move on and talk about securing the software supply chain. Security is the top of everybody's mind these days. So we want to make sure that we can apply policies and controls proactively. We need to rely on security automation. We can't just wait for the security team to test things once we've got them deployed out to our QA or pre-production environments. We need to build security checks into the CI/CD pipelines, and we need to strengthen the security posture. So let's talk about ways in which we've done that. So pre-commit, we look at things like threat modeling, trying to determine where are we going to most likely see threats in our application. IDE security plugins and pre-commit hooks, making sure we've got secure code standards and we're following those. And so when we do peer reviews and things like that, making sure that we're not only looking is the code efficient and is it providing all the functionality, but is it secure? And then moving on to when code is committed, uh, leveraging static code analysis and providing security unit tests, but employing dependency management. We have so many dependencies these days because of how we're leveraging open source and inner source. We want to make sure that those dependencies that we were pulling into our code are secure. When we look at deployments, we want to leverage things like infrastructure as code. So that might be Azure Resource Manager templates, ARM templates, or Terraform, or things like that. So we can, by leveraging those types of infrastructure as code, we can ensure that what we're building out in our development and test environments matches what we have in production, except maybe for the level of scale. So that when we deploy to production, we've already tested out the deployment end to end because those environments match the structure of what we're going to be deploying to in production. Security scanning, for example, when we push a container image out to Azure Container Registry, being able to scan that image for known security vulnerabilities, leveraging cloud configuration and things like Azure policy and things like that, running security acceptance tests and everything. Analyze, make sure you've got security smoke tests in place, configuration tests, doing penetration tests. Now we take that approach where we assume breach. So we have teams here at Microsoft and GitHub that are constantly running penetration tests to ensure that we're not introducing new holes into our code. And operating, continuously monitoring for security issues, looking at threat intelligence, like I mentioned, penetration testing and everything. And this is a great place to mention that Microsoft spends over $1 billion a year on cybersecurity, and you can leverage that by leveraging the tools that Microsoft provides. Blameless postmortems. When things do happen, and they are going to happen, maybe it's a piece of code gets introduced that tanks performance, or maybe, heaven forbid, a security issue does get through, gets past the initial tests and stuff. But whenever any of these things happen, we want to do a blameless postmortem. Not try to find who to blame for the problem, but find out why did this problem occur and how can we prevent problems like that from happening in the future. So one of the things about blameless postmortems, we're not looking for blame. We want to find out what went wrong, learn from that, and apply those learnings to future work, future deployments. So David Blank Edelman, a senior cloud advocate at Microsoft, I recently heard him say, you can't fire your way to security and reliability. So let's leverage those blameless postmortems so that we can uh, learn from what we're doing and improve things next time around. All right, so now here at Microsoft, we can leverage things that are built into our tools. We can help you secure your use of open source and all of your source code from end to end by leveraging things like Dependabot that are built into GitHub. You can scan the packages that you're pulling in through NuGet, NPM, Maven, etc. for known vulnerabilities that are out there in open source packages. And with GitHub Advanced Security, you can even query your own code for patterns of code that may lead to security vulnerabilities. And, and that helps with both open source repositories and your enterprise code. And the other thing about the way we've brought these tools to GitHub, we bring that open source mindset to GitHub Advanced Security. So that means you don't have to be an expert in writing code QL queries to scan your code for known patterns that may lead to vulnerabilities. You can leverage the queries and the work written by security experts at Microsoft, GitHub, Spotify, Facebook, other enterprises like that. So you can leverage the work of some of the world's best security experts that are out there. All right, so moving on to the next area, let's talk about building for resiliency. So here we want to talk about prioritizing reliability and resiliency. Not just saying, well, development's done, I'm going to throw it over the wall to operations, now it's their problem. No, we want to build resiliency and reliability in from the start. So these apps of the future, they have to be resilient. They have to be able to recover gracefully from failures and continue to function with minimal downtime and data loss. We want to make sure we've got high availability, being able to run as designed in a healthy state with no significant downtime during disruptions. So we need to look at our service level indicators. Look at those indicators to tell us, are we maintaining that reliability? We need to have those service level objectives that help us to say, no matter what, we're going to ensure that we've got certain percentage of uptime and availability. But also, what are our recovery point objectives? If something happens, how quickly can we respond and recover? And what are those recovery time objectives as well? And a key to this from a culture perspective and a customer satisfaction perspective is we want to be very transparent. Like we said, issues are going to happen. There's no way we can get around it. So we want to be transparent. We want to let our customers know that, hey, yes, we're aware that an issue's out here, and here's the things we're doing to remediate that. And not only that, but letting our customers know once we've gone through a full root cause analysis, and let them know that we're working to ensure that the problem is not going to resurface again in the future. So we work towards handling live site incidents. One of the things we say to our feature teams here is you build it, you run it. Now, a key thing there is on detection of a live site incident, we'll create a conference bridge, and the people who are the directly responsible individuals will jump on the call for communication both externally and internally. Now, what's a DRI? What's a directly responsible individual? That's somebody from the feature team who has been designated to keep an eye out for production issues during this particular week or this particular sprint. So during that time, they're not responsible for feature work, but they're responsible for the love and care of the production environment. And if an issue pops up, they're the first ones that dive in and try to figure out what's going on. Or if everything's running fine, maybe they're looking into, performance improvements and things like that rather than working on features in that particular sprint. And they're going to dive in and gather data for repair items and mitigate for customers as soon as possible, recording every action. And they're going to we rotate these DRI people during long-running live site incidents. And so we create and track repair items to prevent reoccurrence and improve detection time. So there may be a short-term remediation that we can apply and make sure we get back up and running as quick as possible. But that quick remediation may not be what we need to, for the long term. So we want to create repair items that go on back on the backlog. And you can see an example here. So after this incident occurred, there were a couple of items that we added to the backlog uh, for the next sprint to say, okay, here are the changes we need to make to ensure that this problem is not going to happen again. And like we said, we want to have those shameless and blameless post-incident reviews. So we're not looking to pin blame on somebody, but we're looking to learn what happened. Let's take that growth mindset and learn from the failure that we had and apply those learnings to our next sprint, our next iteration, so that we can move forward in a even better and stronger way. All right, but we're not done. Our journey continues. Here we are in 2020. We've been dealing with the pandemic and everybody's shifting to working remotely. So we're not able to have all our feature teams together in the team rooms like we used to. So moving forward, we have to look at remote work. And we've been measuring our productivity year over year, comparing 2019 and 2020, the number of pull requests that are being acted on, and how long it takes to uh, uh, complete those pull requests and things like that. So we're working to empower information sharing across teams and organization with things like wikis and GitHub pages sites and other things like that that discuss best practices for working from home and keeping your teams engaged and things like that. We really encourage video conferencing whenever we get into a Teams meeting or a GitHub using a Zoom call. So by using video, we can make sure we maintain that human element. And we can see the facial expressions that each other has, and you can still feel that you're interacting as a human and having these very important social conversations and things. Another thing we encourage is creating culture channels within teams to collaborate and have virtual hangouts. So these culture channels might be something like we've got channels for people that live in the Seattle area, the Chicago area, the London area, or there's teams out there for bicycle enthusiasts or teams that are interested in sports and things like that. But giving our team members a place to have those water cooler conversations that they're not having because we're all working from home instead of working in the offices. Schedule virtual lunches or coffee breaks, again, just to have that social element. Just recently, here we are in the holiday season here. We had a team Zoom meeting since we couldn't get together for our typical Christmas meeting, and it was great. It was a way to take a break from work, but still interact with our colleagues in a more fun way. Do check-in calls with teammates, and in doing those, you don't necessarily have to do those with the video sitting at your desk. Take those calls while walking around or getting outside and getting some fresh air, just to break up the day and get away from the virtual meeting fatigue. But a top priority is to keep our employees informed and also watching after our employees' well-being and things like that. Now, another thing we're doing here as we move forward is, you know, wider adoption of GitHub here at Microsoft. So GitHub is the largest developer community and platform in the world. It's home to over 56 million developers, and the world's open source projects are out there and powers thousands of the world's most innovative software driven companies with enterprise capabilities in source code management and collaboration. GitHub's mission is to be the #1 DevOps product on the planet. And our goal is to help GitHub achieve this mission by becoming their first enterprise customer and getting GitHub fully integrated into Microsoft engineering. And Microsoft's mission is to empower every person and every organization on the planet to achieve more. So by combining the mission of GitHub and the mission of GitHub, we're going to empower all developers across the globe to achieve more. And Microsoft is aggressively working towards enabling internal engineering teams to use GitHub, not only for open source, but for private source. And the One Engineering System team is driving this program in partnership with GitHub, the Azure DevOps group, and other engineering systems teams within Microsoft, and a few product and service engineering teams that want to be early adopters as part of the pilot program. So if you've been following what we've been doing at GitHub over the last year, you've seen the strides we've made in enabling GitHub to be an even stronger enterprise DevOps tool set. So to kind of wrap things up here, I want to provide some resources. So after watching this video, you can learn more about DevOps at Microsoft. You can learn more about building modern applications on Azure and leveraging some of the great functionality out there like cognitive services with speech to text recognition, or the vision APIs, or embedding machine learning into your applications and things like that. Learning more about GitHub and DevOps practices so that you can create your own software development assembly line so that you can achieve more and provide more value for your customers. So let's start out with Microsoft's DevOps journey. We've got a great set of white papers and videos out here at aka.ms DevOps Stories. Learn how we're changing the culture across Microsoft, not just what we've been able to do with the Azure DevOps and 1ES teams, but how all teams at Microsoft are learning how to collaborate across teams, how they're learning to leverage that growth mindset and enabling change through technology. Or dive deeper into that 10-year journey of the Azure DevOps team by looking at aka.ms/DevOps at Microsoft. Here there's a number of narratives and videos coming from the leadership of the Azure DevOps team over the years to talk about how we've evolved our teams, how we've evolved our agile practices, how we've learned to deploy Azure DevOps in such a way that we control the blast radius of new features by deploying to one ring at a time, and then expand out to larger and larger user bases, and many other things to learn about the Azure DevOps 10-year journey. And you can learn more about Azure and GitHub and Azure DevOps at Microsoft Learn. This is a great tool to dive in and learn more. And you don't even have to have an Azure subscription to learn how to use, whether it's machine learning or infrastructure as code and things like that. We'll provide you sandboxes that you can use during these lessons to dive in and get hands-on experience with Azure. And we've even added a number of learning paths specific to DevOps and GitHub. So you can dive in and learn about how do you take that open source mindset and bring that internally to your organization to develop a culture of inner source and apply that across all of your teams. So hopefully these resources will be very helpful for you to dive in and learn more. And with that, I want to thank you very much for the opportunity to talk with you today. And I want to wish you the best of luck in your DevOps journey. Thank you. My name is Dave Burnison. It has been a thrill to present this to you today.